In note 6.4, example 8, we're going to practice graphing general sine and cosine functions. And I want to teach you a method where we can account for all the transformations at once rather than graphing the parent function and then applying transformations one at a time like we did in the previous days when we were just graphing sine and cosine functions with simple transformations. So this is the method that I prefer. I hope you like it. I've summarized the method in this box over here, but I don't want you to read that now. I want you to follow along. That's just there as a reference for you for later. So the first thing that we want to figure out is the axis of oscillation. The axis of oscillation is sometimes also called the midline. That's the line about which the sine or cosine function is moving up and down. So in order to find that, we're going to look at vertical shifts. So since this graph is shifted up 4, it's going to be the d value is going to be y equals 4. Next thing we want to look at is the amplitude. So in order to determine the amplitude, we look at the a value, this coefficient outside the function. So the amplitude for this function is 2. The next thing we want to figure out is the period. So the period is always 2 pi over b, and b for this function is 1. So it's 2 pi over 1, which is 2 pi. And when we make our graph, what's going to be important is the intervals for the key points. So key points occur every 1/4 period. So in this case, we're going to have key points at 1/4 times 2 pi, which is every pi over 2. That's going to be important when we make our scale. The next thing we want to look at is a starting point, because once we know one point, we can graph all the other points on a sine or cosine graph because we know the pattern that the graph will follow with key points every quarter period. We'll go from a midline to maximum to the midline to the minimum, etc. So if we transform one point, that would be fine. So for sine of x, if we were graphing sine of x, a good starting point is 0, 0. And now, just like we've done with other functions, let's see what happens to x and y values and then transform our starting point accordingly. So what's happening to x in this function? So x values, there's no dilation. The only change is left pi over 2. So actually, instead of saying left pi over 2, we really want to subtract pi over 2. So our 0, 0 point will become negative pi over 2, 0. And what's happening to y values? Y values are getting multiplied by 2 because we have a vertical stretch by a factor of 2, and they're being shifted up 4. So we started at 0, so 0 times 2 is still 0, so that doesn't change our point. And then we shift up 4, so we get the point negative pi over 2, 4. That's going to be our starting point. And let's see, we want to start putting some of these things on our graph. One other thing we want to look for is reflections. So no reflections here. So our sine graph will start going up from our transformed 0, 0. And I'll explain what I mean on that when we start graphing. All right, let's put all this information onto the coordinate plane that I've included down below. Okay, so when we find the axis of oscillation, we're going to put that on. And we could have done this as we went. I did the full analysis, but you might want to, in the future, put the pieces on as you go. So always put a scale on the y-axis. So I'm doing 1 square is 1 unit. And I want to put on the axis of oscillation, which was at y equals 4. So I'm going to draw in a dashed line at y equals 4. This is our axis of oscillation, or if you want, you can call it the midline. And then from there, we're going to go up 2 units and down 2 units. So because of the amplitude. So I'm going to draw a dashed line at y equals 6. That's going to be the maximum values. And then I'm going to draw a line down 2 from the midline. So at y equals 2, that's going to be where our minimum values occur. Then we're going to look at the intervals for our scale on the x-axis. So we know that we'll have key points every quarter period, which is pi over 2. So I'm going to want to count by pi over 2. So I'm going to start counting. So my first value on the x scale, pi over 2, is here. I'm going to move over 2 more squares. That would be 2 pi over 2, which I'm going to simplify to pi. 2 more squares would be 3 pi over 2. 2 more squares would be 4 pi over 2, which is 2 pi. 2 more squares are going to be 5 pi over 2. 2 more squares would be 6 pi over 2, which is 3 pi. Then I'm going to put on the values in the negative x direction. So negative pi over 2, negative pi, negative 3 pi over 2, and negative 2 pi. And I didn't mention before, but by drawing in the minimum y equals 2, the maximum at y equals 6, and the midline at y equals 4, our sine function will be bouncing around inside this envelope. And all the points that I'm going to plot will be on one of these 3 lines, the midline, the maximum, or the minimum. Okay, so now we're ready to start plotting points. So we know our starting point is negative pi over 2, 4. So I'm going to plot that, negative pi over 2, 4. And now a sine function normally will start going up as we go from left to right on the parent function. And since this graph has no reflections over the x-axis, this will also, no reflections at all, this will also start going up. So from the point we plotted, negative pi over 2, 4, the next point as I go to the right will be at a maximum, so 0, 6. The next point will be back at the midline, pi over 2, 4. The next point will be a minimum, so that would be at pi 2. Then 3 pi over 2 is back at the midline, so at 4. 2 pi is back at the maximum, 2 pi 6. And we can continue on with this pattern. And then once we do that, we can connect these points with a nice smooth curve, and we will have graphed our sine function.